As I have already gone through explaining the peak meter and the RMS meter and what those signify to us, it's time to go over the LUFS metering, and that's loudness units full scale. Now, those loudness units, they come out of a recommendation of the International Telecommunications Union, and out of those we have standards created. Standards for, let's say, European Broadcasting Union, and they made a standard which is going to actually allow for broadcasting of more balanced volumes in all of the programs. So that means radio and TV as well. Now, why is this significant to us as doing music? So let me boil it down for you with some, if I can, simplicity. This standard is not just made for measuring that RMS, it's also made for measuring true peak metering, and I mentioned that already when I was talking about the limiters. So measuring true peaks, the peaks that could happen in between samples. That's why we have limiters that can actually calculate for those and even introduce oversampling. Now, on account of the recommendation of International Telecommunications Union, we have standards made. This one, let's say, for European Broadcasting Union, that uses the LUFS metering. And as I said, to boil it down for you in simplicity, it's measuring, for us, what's important is it's measuring the loudness. But before it measures the loudness in that RMS kind of way, so root mean square, measuring the average value of the signal. So as I've said, to boil it down into some simplicity, since this standard is not just about measuring, loudness or just the true peak, it's a lot of recommendations that brought to a standard being developed in broadcasting loudness. So what is significant to us is that before measuring that loudness in an RMS kind of way, there are certain filters applied to the signal, and those filters are a high pass filter or a low cut. That's somewhere around 100 hertz. It actually is at 100 hertz, starting at 100 hertz going downwards. So signal is filtered out below that portion, below 100 hertz, it's all filtered out. And we have a shelf filter starting at 1K. And that high shelf filter actually starts at 1K and boosts signals for 4 dBs. So it boosts 4 dBs up from 1K and cuts below 100 hertz. Now those two filters are applied, and after that the RMS is measured, so loudness is measured. Now, why is that significant to us? Why would we measure loudness in such a way? Well, that is because to our ears, the frequencies that really matter in loudness are those mid frequencies, let's say from 2K up to 4K, 1K to 4K. Those frequencies are the ones that we hear the most. And if you remember from our digital audio workstation course, when we talked about the Fletch and Manston curves, we learned that not all the frequencies have the same loudness, apparent loudness to the human ear. So even if I played you let's say a sine wave at all the frequencies, let's say every 100 hertz in the entire spectrum that you can hear, not all of those would sound identically loud to you. Why? Because your ears don't detect all of the frequencies with the same loudness, and that also depends on the actual amplitude of the signal. So the louder it goes, the more flat somewhat it becomes. But this meter is actually taking that into account, meaning that now when we measure the loudness with this meter and with those filters applied right before, we actually get a better sense of loudness, of how loud that signal is actually going to sound to a human ear. Now, I suggest getting familiar with meters like these, since these are the future of sound and broadcasting. And quite soon, hopefully, this whole loudness war with music becoming louder and louder and being mastered to be louder than life is going to stop. And then we are going to have standards introduced into how loud actually a song should be for any kind of medium. And we will talk in the next lesson about different services that actually already apply certain standards to the loudness of the songs. So what you should know is when I play this, just play a tiny bit of it. So you can see all the measurements right here, the LUFS measurements for short-term integrated, and we have those maximum values for those, we have true peak value. So if I place a limiter right there on top of those, right here, I place a limiter, and let's say I boost this up. I'm going to pull the volume down so that I can actually talk to you while this is happening. So let's see what's going to happen right here. So I'm going to put 0.3 right there, and I'm going to pull the volume up. Now our meter is before the limiter, so it's not showing us the actual value. Let me put it after, right there. Now we can actually see the loudness after the limiter has been applied. So this is the loudness in loudness units full scale. This is already too loud, as I've seen on the meter, and as I can tell you from experience, this is actually going to give you a better idea of how loud something is with those filters applied before the actual measurement. Why? Because you don't hear all the frequencies in the same subjective volume. And if this is something that will actually help you decide how loud something is, well, you should definitely learn how to use it. So get familiar with the new standards coming out, because this already, as I can see, is the 4th iteration of this recommendation upon which all the standards are being made. And as you can see in the actual pro version of this plugin, you can see different standards for streaming. Spotify, Audio Engineering Society streaming, recommendations, Spotify, YouTube, Apple Music, Tidal. So all of those are actually different standards that we don't even know what Spotify is actually applying, how they measure, but from actual tests that people have made, it's somewhere around -14 LUFS, as much as I know. So different streaming services apply these standards to the music that you're listening to. In a sense, they want all of the songs that are streamed from their streaming service like Spotify to be equal loudness, so they take care that they are. Meaning that if a lot of people, if actually everybody is consuming music through streaming services and you're pushing your music into the limiters to sound louder, there is no sense to do it. You're actually getting more compressed music that is in the end just going to be pulled down with the volume to actually be as loud as everything else is. So you are ruining your dynamic range, your dynamics of the song, and for nothing. In the end, if it's all going to be consumed through streaming services, it's for nothing. You're making the song louder for DJs who are going to be playing it. Be aware that you can use this tool to actually gain knowledge on how loud your signal is. And if that's the case, and I'm telling you it really is, so be familiar with it. Learn how to use it. Play somebody's tracks, finished, mastered music through that. And even if you have to go really super cyan, like super loud with the song, with the mastering, this is at least going to tell you how loud you need to be to get there.